Hey, Jonathan here at Colfax Math. Today I was going to go over number line, graphing inequalities on a number line, open circle, closed circle, and I'll put the links to this project in the description. So if you had x is less than -2, it would go there. It would be an open circle. The rubber band would go that way with an arrow. If, say, you had x was greater than -2, you put it that way with the arrow on it. Or if it was greater than, let's say x was greater than or equal to 3, you'd use a closed-in circle and put it on there. So I'm going to go over a little bit more about this and how to build it, and then how to solve inequalities.
Laminated overnight on
Before we start looking at inequalities, let's start by looking at equalities. So if I have an equality, that means x is equal to 3. Equality equals equation, they're all the same thing. If I had 5 plus x equals 20 and I want to solve that equation, I would add -5 to both sides to get x by itself, and x would equal 15. So that's how I solve an equation. I reverse the operation to isolate my variable x. So then an inequality means that it's not equal to. So if I had something like, say, x is less than 5, what that's saying is x could be any value that is less than 5. So I could draw that graphically on the number line. Here's 0, here's 5. It could be a 4, a 3, a 2, a 1, a -1. It could be any of those, -10 million. So it's all of these values to this side. So I draw an arrow to say it's going to be every one of those values. Because it is less than 5, I don't want it to include 5. So I don't put a dot there because I don't want it to include 5. I actually put an open circle there to say it does not include 5. If it were both an inequality and an equation, so it would be x is less than or equal to 5, then I would color in that circle to say it could be 5, it could be 4, 3, -20. It could be equal to 5 or anything less than. Okay, so if it is only a less than or greater than sign, it is an open circle. If it is a less than or equal to, greater than or equal to, it's a closed-in circle. And that's how you let the reader know that it includes 5. So let's look at another one here. Let's say x is greater than -3. I'm going to draw my number line. Here's 0, here's -3. It does not include -3, so it's an open circle. And then it's everything greater, so something like -2, -1, 0, 1, 10, 20, a million. So it's an arrow going that way because it's greater than. Okay, let's look at another couple too. Let's say I have x is less than or equal to -7. So I create my number line. Always put 0 on there. -7's down here. Is it going to be a closed circle, an open circle? Because it's equal to, it's a closed circle because it includes -7. If I took -7 and put it in here, it would work. -7 is less than or equal to -7. And then it's everything less than that. So -8, -10, -a million. So my arrow goes that way. So go ahead and pause the video and do those 4 problems, and then I'll go over them. Okay, hopefully you paused the video and tried those. So here's my number line. This number line is actually the number line x. It's one-dimensional. Here's 0. If I put a vertical line in there, it would be y, and then we're in two-dimensional space. X is greater than 17. Now my points are going to be a lot closer together. I'll just put 17 here. Open circle or closed. It is equal to 17, so closed circle. It is greater than or equal to 17. So arrow to the right. Next one, draw my number line. Here's 0, here's 3. Dot goes over 3. It is an open circle because it is not equal to it. So that's why the thing's open. It's not colored in. it's less than something like 2, -10, -20, so my arrow goes to the left. Here, x is less than or equal to 0. I'll draw my x-axis. Here's 0. Open or close circle. It is equal to 0 or less than it, so a closed circle. And then everything to the left. And then I could pick an answer and plug it in and check that. Let's say -5 would be my solution. Is -5 less than or equal to 0? Yes, it is. So my graph is correct. X is greater than -5, my number line, 0, -5. It is not equal to -5, so it is an open circle. And it is everything greater than, so everything on that side. Again, I could just pick any value in my solution. Let's say 2. Is 2 greater than -5? Yes, it is, so that works. Okay, so that's a general overview of inequalities. You really build on this a lot through all high school math. But let's take a look at a couple with equations, or let's take a look at them where we have to solve the inequality. So again, if I have x plus 7 equals 10, I solve that equation, not an inequality, but equation, by adding -7 to both sides, and I have x equals 3. I could graph that on my number line. I'm saying x is equal to 3. It's just a dot right above 3. Inequality is the exact same thing. If I have x plus 7 is less than 10, I treat everything the same. I treat it just like a equality equation, and then I figure out the inequality afterwards. So I'm going to add -7 to both sides. That'll give me x by itself. X is less than 3. It is not equal to 3. So I have an open circle here. And then it's less than that. So what's a value that would work? Well, 2 would work. -5 would work. -1,000,000 would work. So my arrow opens that way. Let me put a few more here for you to try. If I have x plus 5 is greater than or equal to 12. X minus 3 is less than 8. X plus 4 is greater than 13. So go ahead and pause the video and do those 3 problems, and then I'll do them after you. Make sure you graph them as well. Okay, so hopefully you did those. I'm going to subtract 5 from both sides. That's going to cancel with that. I'm adding -5 to the 5 to give me x by itself. Then x is greater than or equal to 12, and -5 is 7. So x is greater than or equal to 7. I'll draw that. Here's my 0. Here's a 7. Open or close dot. Well, it's equal to, so it's a closed dot. It is greater than or equal to, so it's an arrow to the right. Next one, I have x minus 3 is less than 8. I want x by itself. I'm going to add 3 to both sides. Those will cancel. Give me x by itself. This is still less than. 8 plus 3 is 11. X is less than 11. Here's 0. Here's 11. Open circle, because it is not equal to 11. It is only less than it. And then it's to the left. And then the check is I could pick any number to the left of it. Like let's say 1. And I plug 1 in there. 1 is less than 11. -2. -2 is less than 11. Do this last one. -4 to both sides to give me x by itself. So now I have x, 4 minus 4, 0, is greater than, if I do that to the left side of the inequality, I also do it to the right. 13 and -4 is 9. X is greater than 9. Again, it will be an open circle at 9 because it is not including 9. And it is greater than 9, so it goes this way. And then you could check any point in that solution set to figure out if that's right. I'm just adding and subtracting with these inequalities. But if I were multiplying, say I had 3x is greater than 21. Now I'm multiplying. The way I would reverse the operation of multiplication is division. So I could divide both sides by 3. 3 divided by 3 would cancel, give me x by itself. 21 divided by 3 is 7. And then I would graph that the same way. 0, 7. It is greater than 7, so it's this side of 7, and an open circle because it's not inclusive. I didn't really want to talk too much about this one here, but this is an important rule to note. If I have negative 3x is greater than 21, I divide by a negative 3. When you multiply or divide by a negative, you switch this sign around. And I could explain that maybe in another video. So this is really important. I'm dividing by a negative. This sign reverses because I divide by a negative. And then now it's saying x is less than negative 7. And then you would graph that the same way over here. So I just want to throw that out. Here's a negative 7. It's less than negative 7. But I don't want to talk too much about it. But it's an important rule to have in the back of your mind. Okay, so let's go back to adding and subtracting. And now let's use our number board. I'll put a link to a PDF of this number board. If you have a laser engraver, you can make one. Some schools do have them. And then I just have a little piece of a pen here for my open circle and a wooden dowel for my closed circle. Then I have a little rubber band here for my arrow. So that arrow, how this arrow works, the rubber band just goes through it and then hooks over the peg. So let's see here. So let's say now I have one of those inequalities. X plus 6 is less than or equal to 14. Again, I want to isolate my variable x. I'll subtract 6 from both sides, and then I'll end up with x is less than or equal to 8. So I notice right away it is a closed circle. So I'm going to take this open circle peg out. That peg comes out, and I use my closed circle peg. Right, so that's what I'm calling a closed circle. It is at 8, so it goes in at 8. And then it is everything less than or equal to 8. So then I hook my rubber band on there, and I pull it down that way. And it is everything less than or equal to 8. So that's how I could physically display it on my number board there. Let's try another one. Let's try x minus 3 is greater than 2. So I need to get this x by itself. I'll add 3 to both sides. That'll give me x is greater than 5. Open or closed circle. It will be an open circle because it is not equal to 5. It goes right in there at 5. And then which way does the rubber band go? The rubber band starts at 5 and goes up from there. So there's my physical solution right there. X is greater than 5. Okay, hopefully that helped. I'm just going to put a few more practice problems down right here. Go ahead and do these either with paper, or if you're able to make a board. You can make this board a lot of ways. You could even do it with paper and pencil, and have the pencil go through the cardboard or paper. So let me put some practice problems here. So pause the video and do these 3, and then I'll do them. Okay, first thing I'll do here, subtract 5 from both sides, or add negative 5 to both sides to get x is less than or equal to negative 2. 3 and negative 5 is negative 2. On the number line, here's negative 2. And it is a closed dot. And it's less than, so it goes like that. On the wooden board, it's a negative 2 with a closed dot. And then the arrow goes that way. X is less than negative 2. And you could pick a point and see if that works. Like in my solution here, -4. That's part of my solution. Puts the rubber bands over it. -4 less than -2. Yep. -7 less than -2. Yep. Okay. This one right here, I'm going to add 5 to both sides to get x is greater than 13. On my number line, I'm here at 13. It is an open circle, and it's everything greater than it. Lastly, I'll add 3 to both sides here. X is less than or equal to 3. On my number line is 0, 3, closed circle because it includes 3, and it's less than everything that side of it. All right, well, I hope you enjoyed this video. I hope you enjoy this project. I'd love to hear your comments below if you figured out a better way to make this number line, easy way to make this at home. I know in this distance learning environment we're in, you got to make do, adapt. So the other thing that this thing's nice for too is it's good for adding and subtracting negative numbers. So if I have -4 plus 5, I could just count out 1, 2, 3, 4, 5. So you should make yourself one of these, whether it's paper, cardboard, pencil, whatever you can make it out of. I'd like to hear your comments below how you did come up with solutions for this. And if you liked the video, hit like and subscribe. This is Colfax Math, the applications of math. Thank you for watching.